Hi, in this video I'm going to go over how to register multiple longitudinal 3D T1 weighted MRI scans from the same subject using the ATRA module of the automatic registration toolbox. So I'm assuming that ATRA has been installed on your system, and I'm going to use the images that are distributed with ATRA under example 1 to run this video. So these images are located at arthome/example1. So as you can see, there are 4 3D MRI volumes here. They are named V1 through V4. Now ATRA requires that these images be nifty 1 images of type short integer. So it won't work if for other types. But in MRI, almost all structural MRI volumes are of this type anyways. So to run ATRA, the first thing to do is create a text file in which we just name the images to be registered. So I'm going to call this text file imlist or image list. So list all your nifty images in this directory and insert them into a text file called image list. So here's what image list looks like. Essentially the name of the 4 volumes, 1 per line. So now we are ready to run ATRA. So before I run ATRA, I'd like to bring your attention to the fact that now there are only 5 images or 5 files in this directory, 4 volumes and 1 text file that we just created. After ATRA finishes, the number of files in this directory will increase to 35. In other words, ATRA will generate 30 different files. So the number of files that are generated by ATRA, by the current version of ATRA, is 7 times the number of volumes plus 2. So in this case, because the number of volumes is 4, so 7 times 4 plus 2 equals 30. So to run the program, type ATRA -i imlist -v for verbose, and then optionally we can give it a output prefix. Let's just call our prefix foo, and here we go. This usually takes around 30 seconds on my system for 4 images. So the program is running and it's outputting some information to the screen. So I'll go over some of this information shortly after the program is finished. Okay, it's done, and it took 33 seconds. Here you can see it reports how long it took to finish. Now, if you look at the output here, the first line tells you that the output registered images are going to be in the PIL orientation. PIL stands for posterior inferior left. So the fastest varying index in the image goes from anterior to posterior direction, and the second fastest varying index goes towards the inferior direction, and the third fastest varying index goes towards left. Now this is the default orientation of the output. You can specify different orientation using the dash orient. So if I add to the command line dash orient RAS, for example, now the output will be in RAS orientation, which stands for right, anterior, and superior. There can be a total of 48 possible orientation codes because we have 6 symbols: right, left, anterior, posterior, superior, inferior, and there can be a total of 48 permutations of these. So in this case, we just ran the program without this option. Therefore, the default orientation was selected to be peel. And the next few lines just reiterate the number of input images to be registered and the name of each of the 4 volumes as read from the image list file. The next couple of lines specify the output size, of the output image, the matrix size and the voxel size. And these are the default sizes that it will be outputted. But let's say you wanted a different size. For example, you wanted the first dimension to be 256 instead of 255, and the second dimension to be, say, 300. So the way to specify that is using dash nx as first dimension, 256, and dash ny as the second dimension. That would be, we said, let's make it 300, and dash nz would specify the last dimension. However, let's just keep it 189. So if you don't specify that, it will just use 189. And then the voxel sizes can also be selected to be different from the default 1 millimeter. So for example, if you want a voxel size of, say, 1.1 millimeter in the x direction, we just use the minus dx 1.1 as our option. Okay. However, we just, in this example, use the default value, so we didn't have to specify these. So now that the program has finished, we see that it has generated a lot of output files, and let's just count them. They will be 35 files created here. We started out with 5 files, now we have 35. So let me go over the most important of these files. Firstly, since we had 4 input images, there will be 4 output images. The output images, however, will be all in registration. They will be precisely aligned, and they will be in PIL format. So the input images were V1 through 4 NII. Excuse me. The input images will be V1 through 4 .NII. The output images will be V1 through 4 again, PIL.NII. So these are essentially the most important outputs of this program, the registered images. In addition, the 4 images are also averaged, so the program will also put out a 5th image, which is the average of these 4 images post-registration. And to name the output average image, it will use the prefix that we specified. So the prefix was foo, so it will create an image called foo average pil.nii. Now, if you had specified a different orientation, say RAS, these file names would be named using the RAS code, RAS, instead of PIL.